Okay, so today we're going to talk about the PCAM5. Now, they have a workshop. I'm going to provide a link. And they did this a few years ago. You can download the workshop. You can download the code. Problem is the code's a bit outdated, particularly for what we're going to be talking about today, which is the standard Vivaldo implementation of a bypass, the video bypass. So you can see in the picture, you can see the camera on the Zybo, and what they created was a bypass using the some custom IP that they built. That custom IP is out of date. So the most important thing is if you download this and you bring it in, do not let it update. Just tell it to keep it read-only. So let's bring that up now. Let's see, is this? Yeah. So this is your IP. So what you're going to do is let me get to the, you're going to do, when you open it, you're going to do File, Open Project. You're going to open the project, and when it asks you, do you want to update, you say no, leave it read-only. Okay, and the next thing you're going to do is you're going to export the hardware. Export it locally, and you're going to end up with the SDK. Now, the SDK, let's go back to the C++ perspective here. So now we're in the SDK, and when you get in the SDK initially, you're only going to see this system wrapper hardware. You're not going to see the BSP or the HDMI pass, and that's when you're going to have to import those items. Once you do that, it should compile. You have your includes, you have your source, the main application, and we'll see that a little later. You've got your board support information. So this is the information about your hardware board that it uses to communicate. And again, your includes. And you also, it's going to compile into your debug. So that's what you're going to see when you get into the SDK. And you can see we've got our main program here that kind of starts everything going. And then this looks a lot like if you've used Arduino, and just a while loop that keeps going, and depending on what you select, it will do various things to the signal. It can change the resolution. It can get stuff out of registers, and we'll see that later. So there's a lot that it can do. It's pretty much, you can look at this and this will tell you. In addition, you've got this method, which is pipeline mode change. So when is this called? We can find where this is called. So this is called right at the beginning. Let's see if it's called anywhere else. Yeah. So it's called when you change the resolution. So it's called at the beginning, and it's called when you change the resolution, from what I can tell here, depending on what resolution you want. So in this case, you got the 720 by 1280. You've got the 1280 by 720, 1920 by 1080, and 1920 by 1080, 35 frames per second and 15 frames per second. So those, and it's also used in the beginning to set it by default to 1920 by 1080 with 30 frames a second. So this is the actual code that's going to run on the processing system, the Zinc processing system, which is our ARM processor. Okay, so let's go. Now, I'm going through this. I'm going to, at a later date, I'm working on a video on the HLS and synthesis. But I want to cover, I think, since probably most people are more familiar with the Zybo, with the Vivaldo, standard Vivaldo, I thought I would cover that first before we get into the HLS. Okay, so we're going to start with this. I'm going to, at a later date, talk about the HLS and synthesis and go through that. And that's actually the first task. But then they go to this and they go back to the edge detection. We're going to go through those. But today we're going to talk about the pass-through. So what this does is it gets configures the camera, gets the data, buffers the data, and then it encodes the data to the output, DVI, and then to HDMI, which I'm going to show you later. You can download it. Now, like I said, it is out of date, so you need to use the procedures I mentioned, which is opening in Vivaldo. Don't let it change anything to say it. Keep it read-only. Then generate the hardware, and then import the actual application project, and let it copy it in here. So let's first go back. And let me go back. So let's now look again at the Vivaldo. This is our design, our block design. And this has a number of 3 main pieces as I go over in the documentation for the workshop. You have your input, so this is the physical, you're coming in from the camera. It then goes to the most critical, being this the memory. This is the coordinator, the AXI VDMA, and you have your memory, and you can see what happens here is what allows it to do is the output, HDMI output, is not compatible with the camera. So what has to happen is, first of all, it comes in, here's our camera coming in. these are like the physical layer. If you're familiar with the 7-layer network model, where you start the physical layer and you build up, you get to the TCP, et cetera, up to the presentation. Similar type of thing. It comes in here as bits. It's put into frames in this guy here. And then it goes through some transitions as your AXI. So it's taking this, starting to turn it into RGB. Now this is our DVI clocking. So one of the reasons of the incompatibility between the camera and the output is they have different clocks. And once you start looking at FPGA and VHDL, clocks are critical because you're getting down to the circuit layer. If you play with electronic circuits, digital circuits, the clocks make all the difference. For example, if you talk about the Arduino, you may have things working on a particular clock cycle. But it's definitely a big factor in the FPGA world. So then it's in the memory, it's sitting it's now in a position where the output processing can grab it. This is connecting to video out, goes through RBG to DVI rather, and out it goes. Trying to look and see here. You also have your GPIO. So this is probably where it's giving you some feedback on. When we run it, you see the text going to the screen, and this is where the C code is run. So this is your basic design, and they go over it in the documentation. Now, one other thing, let me bring that up. Let me go to that screen. This is very interesting. This here is what you're looking at now is some of the VHDL code as opposed to Verilog that is actually part of the blocks, part of these IPs. You could think of the IPs that we were looking at as libraries. So if you're familiar with writing C code, you might have a .lib file, or Java, you use tons of different jar files that you have libraries that you use to do various things. And half the battle sometimes is getting them coordinated. But at any rate, this is what these essentially are. But this is the low level. So this is the, let me go back here. This is part of the code for this. So let's go back and have a bit of a look at it. Go. So you can see that your libraries, this is pretty standard for your VHDL. And HDL stands for Hardware Definition Language. And the two main ones, VHDL and Verilog. And the Vivaldo tool supports both. And Adam is giving this weird character thing. But here, this part up here, let's see. This is output. This is the input and output here, the port. And it's defining all the inputs and outputs for that module. And this is what you connect up. The module's the input to actually use it. You connect the signals to, and you'll see the signals are defined. And you can see how we're connecting the I/O to the signals here. Now you have a bunch of processes, and they can all run in parallel. Rising edge, that means when the clock edge is rising, and SAXI, a clock, is the clock that's using. Again, you have multiple clocks in something this involved. And it says this is what you're doing when this is a process. So when you on the rising edge, you look and say this, then you're basically moving your data around on the rising edge. And they go into a description of what all these routines do. And again, they can be done in parallel. This is what makes the FPGA so valuable. AW is inserted for one clock sound when both, so when they're both, I guess, is high. Oh, sorry, when it's asserted. And so when they're both 1, slave is ready to accept the write address. And you can see they have a bunch of these. So it's gonna store, the write address when, again, if let's see, it talks about the reset up here. So if reset is low, okay, so if this is deasserted and these are both high, then again so this process is used to store, latch the addresses when both, and it describes in here what all these different processes do on the rising edge. So this is probably this looks like a more involved one. Again, you're moving bits through the system. So this is essentially what these modules are made up of. And you can see how you're moving this data through. So that is basically what you're working with these. Again, these are a lot of these were custom designed by Digilent. So you can actually look at the code. One thing I'd like to point out with the camera, and you can, let me go back to the screen with the camera here. So you can see the cameras here. Now, 2 things, and this drove me nuts. This is a lens cap. You need to take this off. However, you may want to leave it on a little bit just to get this is the focus right here. Your focus. And that was a little tight. Now, on here, what you do to install is you lift this little white thing up, you stick it, you'll see a little slot, and you'll see you want the blue pointed inward to the board, you want the connection pointing outward, and you push that white thing back down and lock it in, and that's how you connect the camera. It's, to me, this camera was not intuitively obvious, but you can see how it is connected here. So going back here, so once you've generated your hardware, what you're going to do, and you're going to bring in your software, and this is their software. here. And basically what this does is what you'll see is there are a bunch of, let me show you the SDK terminal here. So this is running right now, and you can change focus. You can do a number of things depending on the letter. And I'd have to look at exactly what these all mean. So, for example, you can change the, if you hit the resolution, you can change the resolution. So, to different frames per second, different, and I am not sure what it is running at now, but you can change the focus, which is B. And I'm not going to mess with that because I had enough of that. Change the image format. You can change the gamma correction. You can change, so what's gamma correction? You can read a register inside the image sensor. You can, so let's try that. Let's try F. Let's just pick a number. Let's see. Oh, F, A, B. Okay. And you can see, okay. So if we do F again, and we do 21, 21, what did it get? Value desired registered. Let's do F again. And let's see if we can make this a little bigger. So, F again. Let's see what we got for AA. So, different registers, and you can do that. Let's look at which is gamma correction. So there's a lot, you know, they have different things that you can do. So let's say you say you do 5. So what you do is you output to the gamma character that you read. So this has a number of options you can do. And the way you actually run it is you hit this. You can also debug. And you run it through here. This is important. What you want, let me go back to the picture of the, yeah. So what you want here is you want this jumper on your screen. I'm not sure that this has to be, but this is, this has to be set to here for JTAG. Let's show you that, because if it's not hit, if it's hit here and you restart, it's going to put out the test pattern. So you need this here all the way to the, the right, closest to the little sticker there. So let's have a look at that so you can see what's going on, see how it starts up. What I'm going to do is I'm going to stop this? Well, I'm gonna, okay, do you want to relaunch? Yes. So it's going to relaunch. Now it's resetting the system, it's programming the FPGA, and then what you're going to see is, when you go to the SDK terminal, your options. So this is essentially how this works. And again, if you have this board and you have the little camera, I would recommend giving it a try. But remember, it's out of date, so you need to tell it to not change anything when you bring it in Vivaldo. And the other thing you need to do is you need to export the hardware and then import the actual code, this code. And to look at, this is using some of this is their code that uses the actual Xilinx libraries. So, and again, I'll put a link to that. I mean, you can write your own IP, and if you want to experiment and not wait till they update it. But what happened is I wasted a lot of time trying to let it update and try to regenerate it, re-synthesize it. I was running into an issue. Let me go back to here. I was running into an issue on synthesis with one of their IPs, which is I believe it was this, that it was asking for something it did not have. So it was asking for a port it did not have. I even played around trying to add it myself. Didn't that decide to go back and try. Therefore, they do give instructions when you download the up-to-date, and this is also important. You want to download the up-to-date PCAM5 project. They do have a README, and that gives some good information there as well. So let me show you now. Let me turn on let me show you now what this is going to look like. Okay, so you can see, not very exciting. You see my wallpaper, but I can move this around and you can see it is passing through the signal, and you can see the unit right here. Very, very nice. You can see how this works and what you're going to get out once you get this thing working. And to me, it was very exciting getting this working, even if we're just looking at old wallpaper, because I never bothered changing the wallpaper in this room. And for years it was a bird room, so it's just kind of a fun thing to do, a fun little project. And and this is the start of being able to do machine vision and all the rest of it. So what I'm going to do, the next step is we're going to talk about HLS and synthesis and what that all means. And in the previous video, I showed there's some good reference. The workshop itself is a good reference. They go through that stuff, what synthesis is and diagrams. And there is another reference that I really like. a book that I purchased that is available on Amazon that was put out by Scotch University. This is the book. It's called the Zinc book. There we go. The Zinc book. And they go through all this in some detail. What it is, what it does. They go through synthesis. They go through HLS. So those, in preparing the next video, this is going to be one of my major references as well as the workshop. They also talk about IP block design, IP and what those are and how you create those. Those are what we saw with the little blocks of code in Vivaldo. These items, where they have code that you can reuse. And that's the whole point. By making these blocks, they already have code. Essentially, they're in essence VHDL libraries. And that's essentially what they are. You implement something like this, you can reuse it time and time again, and it'll save you design time. And of course, with the VHDL, with the HLS, high-level synthesis, you start with your C code and it generates all down to your VHDL, so you don't have to actually write that. And we're going to go through all that. That's part of my goal on the next lecture. The next discussion is going to involve that. So hopefully you've enjoyed this. I've tried to keep it relatively short and to the point, show you the different things, give you the gotchas on this and how you get this thing to work without getting frustrated, because it did, it did take me a bit of playing around to get this thing to actually do what I wanted to do. So thank you so much for watching, and I will speak to you next time.